All right, thanks. So this is a lightning talk about a 50-year-old book. And the book is this one. This one. And it's by Jean Sammet. Now, Jean Sammet is a name you may not know, but she is an important name in the history of programming. She had a bachelor's and a master's degree in mathematics and an honorary doctorate from her alma mater. She developed the Formac language, Formac, and she was one of the developers of COBOL. But beyond that, she is best known today as being the author of this book, which, in the words of Walter Brown, was her life's work. And this book came out in 1969, and it covers about 120 languages. There are over 800 bibliographic references in this book, and there are examples for all of the major languages that were extant at the time. It's an astonishing reference work, and it's a useful insight into many of the things we think today are new concerns, new ideas, new aspects of the programmer's condition were in fact well known by 1970. So she starts out with definitions, and the definition of a programming language, which seems a bit amazing, but actually, at the time, they certainly needed it. And she said this interesting thing: the user can write a program without knowing much, if anything, about the physical characteristics of the machine on which the program is to be run. And then, perhaps even more tellingly, this same comment does not apply if he, nowadays we would use gender-neutral pronouns, but this same comment does not apply if he wishes to obtain maximum efficiency. So this stuff was new at the time, but the concerns of a we might say a high-level language, laughingly, are the same. The ability to fit the language to its problem domain, portability desires, and the abstraction afforded by the language, distinct from the hardware. So she goes on to list several advantages and disadvantages of so-called high-level languages, bearing in mind the high-level language at the time we would probably now consider to be pretty low level. And just like compilation time being a concern today, it was perhaps even more of a concern then, because almost no matter how long the compilation time is today, we can be pretty sure that the runtime will outweigh it. This was not the case in the late 60s. You'll notice debugging is in both columns. She noted that high-level languages are often easier to debug. On the other hand, when you need to drop into the assembly, as it were, using a lower-level language, i.e. an assembly to start with, will usually result in an easier time debugging, and high-level languages could obfuscate assembly. And at the time, there were many languages. The late 60s was an amazing time for programming language experimentation and all these new languages coming out. Many of them were not general purpose, many of them were special purpose. And so there was the concern that, well, you don't use a string-oriented language to do numerical calculations. They're designed for two different things. And it's sort of an interesting thing to think about today. Many of the other concerns were the same concerns we have now in C++. In the case of a language designed for use by a professional programmer, as opposed to a scientist just working in a domain using programming to solve their problem, major characteristic is to provide maximum capability. And we as professional programmers almost always want to be able to get at the machine code. And this is our life today. We always want proof. We have Compiler Explorer to help us out. Trust but verify. She also said it should be kept in mind that the language and the means of defining the language are not the same thing. And somehow the standardization process must avoid eliminating or preventing technical progress. And again, just from 50 years ago, we live this in C++. We do not define an implementation. We define a standard, we define a spec, and somehow we have to move forward with that spec while allowing technical progress. The same concerns we have today, they had 50 years ago. She also warned us not to judge our STL implementers based on what they implement, because they were bound to implement that by the standard. The usefulness of the language must be judged independently of the compilers which implement it. And something we should remember about C++20 perhaps is only after a language has been in use for a while can its advantages be ascertained. We're not going to see all of the things we can do with 20 for another 5 years, maybe. And in the end, the problems we have today are the same problems they had then. The complexities of today's large computers make it very difficult to learn to program them at all, let alone effectively.